So that's good. Not, what is it? I can't get this to turn on. Help! I was like, oh no, are you guys gonna be here? For what?
New markers,
Ooh.
in case you need them.
Oh, that's fun.
Okay,
Uh-oh, our number.
you have to be
I can rewrite the number up there.
on VGA,
Oh, that's probably
and
why I
you have to
didn't
go
work.
through the VGA because you have a Mac. Because apparently the HDMI
I was trying
and
to go
Macs are unhappy.
All right. I remember you guys saying that, and I just.
And I brought bought markers because none of them here were working. I got it. Yeah,
Sometimes you have to, oh, there you go.
it just takes it a minute in the morning. It's very
Thank you, Lynn,
much like
for
my
writing
son.
that. Tomorrow morning, you don't want Jacob too, but we want to do the M&M Skittle
Oh, okay.
before
Yeah.
class. Well, in the morning of class.
I don't know where Jacob
Yeah.
is. He was supposed to be here today.
He'll get here. He's not a morning guy.
He's not. Oh, thanks, Lynn.
Yeah, you have a better marker, don't need it though.
Yeah.
Yeah, I bought markers.
Hey, real good markers.
Well, they're new. That doesn't mean they're good.
You can use this one up.
I bought 3 or 4 packages of Expo markers, so we ran out of those. I got 3 more upstairs. I know.
It was good for me to build out our worksheet. I usually do stuff like
Make sure you have our studio if you don't yet. You should have done that over the weekend, hopefully.
The link to install is in this 6 worksheet if you did do it over the weekend. And you just want the free version for if you have either PC or Mac.
Maybe scared them all.
Yeah. Clearly, we scared like half of you guys away. That needs to be the first thing.
Survivor.
You have not been voted off the island yet.
I'll just send you the link, Keybase or email? Keybase or email?
For what? I'm sorry. Oh, I haven't done the capstone. You can Keybase works.
I can do.
No, let's just do Keybase.
Switch computers.
Okay. Yeah.
I have been doing that because we figured out how to work my computer, but now we know.
Okay.
VGA.
That works for me.
I made the mistake of ignoring that on Friday and had a shooting crash so bad Friday, like I don't remember a large part of it.
Yeah, I noticed you didn't show up to class. Shall we send out a rescue unit next time you don't show up?
Sucks to be reactive in the
Okay, view, presents.
Probably have to redo that once it's connected. Yeah, now I'm good.
Okay, everybody, we're gonna get started even though we're clearly missing a portion of the class now. Okay. You guys do not know this, or you may know this, but you've been dealing with toy data. So it is not as big as your real data will be. Why that matters is because everything in class is running very quickly. That does not mean your data will run very quickly when you get real data, because it is much, much bigger. So we're going to talk today about file size, because a lot of what we're going to be doing is on RStudio, which we've had you install on your computer. When files get small enough, it is easier to work on your computer than the supercomputer. But before you start this, you don't actually have an idea of how big the data you're dealing with is and which files are small versus not. So this is not to scale, but it gives you a general idea, okay? FOSQ files are pretty big mostly when they come off the sequencer. It depends on how deep you sequence. The deeper you sequence, the bigger they will be. The more nucleotides, the bigger they will be. You then map and get to a SAM, BAM, or CRAM, depending on how you're mapping. You guys have dealt with all of these files. SAMs are the biggest of all the file types you will deal with because they have all the information that was in the FOSQ plus all of the information about mapping. BAM is simply a binary SAM. In other words, they have made it smaller by pushing it into binary space. We haven't yet dealt with CRAMs, but you probably will. That's an even smaller BAM. So again, they're just compressing the data. The easiest way to think about data compression is the idea that if you have 10 zeros in a row, you can either say 0, 0, 0, 0 and take up 10 spaces, or you can say 10 zeros. And so compression is doing that kind of thing. It isn't necessarily that exactly, but the idea of trying to smush the data into a smaller space. So those are the mapped files. They are very big. And therefore, the first thing we're going to learn about is counting out of those mapped files. And that is something you will probably want to do on a supercomputer because those files are so big, you don't want to put them on your computer. Now, some of you could have put the ones we gave you on the computer because the ones we gave you were just chromosome 21. Of course, we're going to have computer problems. There we go. The ones we gave you were just chromosome 21, so those BAMs probably did fit, but the real BAMs you get probably won't. So what do we do about that? We add layers of compression by just taking the information we want out of the file. So all of these formats over here, bed, bigwid, bedgraph, and TDF, are all just parts of the data. So SAM and BAM are going to have every read, every map, every mismatch. But when I want just the regions, like in ChIP-seq, I can go to a bed file. When I want just the histogram of how many reads per position, I can go to a bigwig or a bedgraph, okay? So there are ways of making that data much smaller. When you get to a BAM, bigwig, bedgraph, TDF, those are small enough they will fit on your computer. And because every time you work on the supercomputer, everything you type has to be transmitted to the supercomputer and back again, it is sometimes worth it to not stay on the supercomputer. So some of what we're going to be doing today is in R on our own personal laptops. Once you get to a small format, like the count text file we're going to do today, then you can move it to your computer and work. And that is what we're trying to teach you. When is it okay to do it on when is it okay to do it on your computer versus when do you have to do it on the supercomputer? Okay? So we're going to talk about the file sizes and what parts of the path. Today we are going to get through the fact that we've already gotten through FOSQ and a BAM. We're going to be counting and creating accounts, either CSV or text file. And at that point, you can then move to your own personal computer because it is small enough to deal with the data on your computer. Who here is going to be on Fiji when they're done, meaning BioFrontiers people? You guys, there is a Fiji visualization RStudio, meaning in RStudio you can run off of the supercomputer. Most supercomputers don't have that. And so if you want to use RStudio, you'll be doing it on your own laptop. Okay, so you have been learning Bash, and Bash is like the Model T of computer languages. It was written before I was born, and most of these commands are therefore very old. More recent, although not terribly more recent, is R. However, R's been developing over time a lot, so you're going to feel like you're driving an entirely new machine. And you kind of are, because R is not driven the same way Bash is. But under the hood, it's very similar. You're still turning things on, loading things up, setting variables. All of those are the same. They're just done with slightly different syntax. So when you go to type something, you actually have to remember which you are in. Are you in R? Are you in Bash? Are you in Python? Because you have to follow the rules of their languages. It's sort of like If you can speak Spanish, you can speak a little bit of Italian. That's R versus Bash. So some of them are the same and some of them are slightly different. And you'll just learn the differences as you go. R is super cool because it's really the best statistical language and it's easy to pick up. It is not necessarily the one you want to code in. If you're going to be doing massive amounts of data manipulation, you may want to move to another language, but R is quick and easy to pick up and great at drawing things. I mean, I've written in Python for 10 years and I still go to R for most of my pictures because they're prettier. You specifically will be using RStudio. RStudio is not really a separate program. It is a wrapper around R. So on the server, you will use R, not RStudio. And then when you move to your own laptop, it's just easier to use RStudio because they show you the code. They show you in one part it's got where you're actually coding the script. In one part it's got where it's running. In one part it's got where your files are and your variables. So it's just a prettier version of R, and actually it's not really running R by itself. It's using the R that's already on your computer. So you would get the exact same R if you just opened your terminal and typed the letter R. RStudio is just a prettier way of looking at it. Okay, again, red and green sticky notes are how you tell us if you need help. They were sitting up here by the face mask, but they may be passed around at this point. Anybody know where the sticky notes went? Oh, there we go. They're right there if you need them. If anybody needs them, we'll put them up front. You can come get them. And I will let Taylor take over and teach you guys how to drive in R. Have you guys seen the new Tesla that was on that picture, by the way? It's got no speedometer at all. It's all on that little computer in front of you. Can you imagine driving a car without a speedometer? I don't think you want to try this.
They can't give you any speeding tickets, right?
They can, but your speedometer comes up only when you need it on the screen. And you have to trust the screen to give you that information when you need it. I'm not sure I trust computers that much.
Okay. So like Mary said, we're going to be working in R today, which probably seems a little scary, but it's not. R is super, we're going to start on command line like Mary said you can do if you ever have to do this on a supercomputer, so you can get a little familiar with it. And then we're going to move over to RStudio, which is a much more user-friendly way to actually code in R. And we're going to spend about 80% of the time doing that, and then the last 20% we're actually going to count over the BAM files that you guys generated last week. I think it's worth spending a good amount of time on R because it's gonna, like Mary said, make some beautiful plots. Like you get all the way through your data analysis, you're going to the publication phase with these big old tables. Like how do you make a plot out of them? How do you get a publication-worthy figure? That's part of it, and the other part is you get these big old tables, they're 20,000 some rows long. Do you really want to open them up on Excel and try to fight with Excel to get the information you want out of them?
The answer is no.
The answer is no, and R is awesome for that. It's essentially, you can think of some of it as like Excel. You're working with data frames.
You're flashing, so I'm going to fix this.
Yours was too. I don't know what's going on today.
Okay, I'll fix it.
We don't have to do too much on the screen today, which is okay. But when you're working with big data, it's really helpful to have something like R to handle these huge data frames. And some of you guys may be familiar, but most of you probably aren't. So if you didn't before class, you'll want to go to this link and install RStudio, or it should be in worksheet 6.1, 6 or 6.1. And you will want to install it for your desktop, whether it's Windows or Mac specific. And we can have that downloading in the background while we perhaps use R on command line. In that PDF file that's on the short-read site, there's a ton of useful resources for after this that you can use to get better at R. R for data science is awesome, and Pirate's Guide to R is kind of a classic manual to learning how to do more in R.
You get the joke, Pirate's Guide to R.
So, terminal. So you can do this on your base machine, if I can get a new window open. I don't even know if we're gonna be able to do this if it flashes on or
I
not.
know, I was gonna try and look it up. I unplugged both VGAs I can leave.
Do you want to try my computer?
The PCs have not been giving us this problem.
The problem is if you use my computer.
Okay.
That may work.
Most
So
of
we
this,
switched the dongle out, we switched the one thing we have to switch out is the cord. But I've checked all the connections and I reconnected underneath.
open up a terminal on your computer though, so.
And if nothing else, this is worksheet one. We're literally going through
We're
worksheet
working through
one.
worksheet 1, and then we'll shift over to an R script and into RStudio, and work off of that script that I pre-generated for us. So this isn't totally essential, but it would be nice to walk through some of it.
I am.
Well, Ariel, all of this is on short read, so we can just pull it up on your computer.
Do you want to use mine so you can keep going through it, Ariel?
Was it? Yeah.
Or you can just take mine, either way, it doesn't really
I'm gonna hide my bookmarks though.
matter. Ooh, what's on there?
A lot of recipes and anime. Yeah, here you go. And musicals, that's so true.
Just straight HDMI works, right? Yes, no.
Yeah, HDMI works with PCs. I'm emailing guys right now.
Uh-oh, I forgot your mouse is kind of jank.
It is.
We'll live.
Okay. Here you go.
I appreciate it. Oh. 108. Okay, so this is the download page for R that Ariel had open. So everyone should have that on their machine. Ariel, I actually need you to pull up like maybe just an empty terminal for you.
With it?
Is that on?
Yeah, it's Ubuntu.
I just ended it because it's slightly, the commands are slightly different. All right, already then.
I don't think she'd use it.
I thought he was on the supercomputer because I didn't look.
Yeah, so I'm gonna desktop that.
Okay. Okay, so once you get a terminal open, you can actually just access R straight onto your terminal by typing R and hitting enter. And is it not big enough?
Oh,
Well, that's gonna be a
log
problem.
on the supercomputer, just use our there.
That is true.
You need the VPN.
No, you don't.
Oh, no.
VPNs are for getting space service.
Oh, okay.
So AWSs do not need VPNs. Oh, okay. That way everybody in the class can get on R, even if it doesn't have R. If you're on a Mac, R is already pre-installed.
Did I have
If
a
you're on a
typo?
PC, it may not be, and you can just log into
Do you want
supercomputer.
to log on to mine?
Oh, it's because I'm not associated with your
Yes,
key.
log on as-
Yeah, I did 2562.
R, right?
Yeah, 2562. There you go.
The minute you use someone else's keyboard, you go like half the speed, if not less. Okay, now we can do it. R and enter. It should pull up R, and you know you're in R because you no longer have this identifier key, and you now have this little triangle, little caret. You are in R. In R, like in Bash, you can assign variables, but first we can do really basic things in R like addition that were more difficult. I don't know how to make this computer bigger. Oh, that better?
Yeah.
Ah, yes.
Scoot it a little bit. Hold the thing.
Ah, there we go. That works beautifully.
Oh, no. It's gone.
Send nice email, hopefully she'll get back to us.
Yeah, I'm not gonna try to do that. Okay, so you can do things like basic addition in R. And R at its root is a statistical software. So one of the things that's really useful in R is you can do things like mean, median, mode, standard deviation. You can also do a variety of tests for significance. So this could be useful in other experiments that you run that you're like, do I need to do a two-tailed t-test? R can do that for you. So you can think of it as like I said, similar to Excel, but it's a more powerful, robust way to do something like Excel. Okay. So in R, we can set variables just like you could on command line. So say we wanted to do this addition using variables. We could do that by saying, okay, let's call variable P and a number, say 9. Now if I call P, it will return 9. We can do that with a second variable. How about R? Because that's fun. And call it 5. And now that we have both P and R, we can actually add them, and it will return the sum of P and R as variables.
Okay, so if you can add two numbers in R, just give us a green sheet.
A lot less of the $ mumbo jumbo you had to deal with last week, right? Spaces do not matter in R.
Isn't that great? Spaces
So-
matter bad.
Right, I did spaces in each of my R and P, you can see up there, but if I wanted to say rename R, I could do this, and it's the same thing. You could add as many spaces as you want. While you are in this session.
So
Just,
if you close R, they go away.
it looks like we're good with that. So you can set longer variables in R like lists. So let's call that a variable L. And to set a list, you need to use C parentheses, and then you can generate a list of numbers. So this is all on that worksheet, but I'm making a random list of numbers because I don't have that worksheet in front of me, and I don't know what numbers I used for that. So there's my list of numbers, and now I have the variable L that contains this list.
It isn't like a matrix?
This is just
Vector.
a vector, yeah.
I know, they have different names and everything. In Python, this would be called a list. In R, this is called a vector. It's really confusing. Although Robin tells me this really is a vector.
This is a vector.
A CS.
I call it a list because I mainly use Python, but they're more or less the same thing. It's a list of numbers, right? Now that we have this variable set as a list, we can start doing some of those statistics I said that we were able to do in R. So we can take, say, the average of L, and it will return the average of our list. You can do a sum of L, and it will add our list up. So you can think of a lot of different mathematical operators that you can perform on a list, and everything that you can do on a list, you can do on a column of a data frame. So that would be like a column in Excel. You can think of that as maybe your counts over all your genes, or a count over a row, which would be a count over one gene for all your samples. So lists are kind of the simplest form to do these things, but you can also think of more complex systems where you can apply these same operators. Mainly what I did in base R. I think you can do, I think I also did standard deviation of your list. That's STD.
Yeah, STD. I know, I never remember either.
That's not it. Ah, thank you. All right, you guys have it. And then to get out of R, you do Q double parentheses, and that pulls you out of R. So like I said, this isn't the most beautiful way to use R by any stretch, but it is the actual base R functionality, and this may be what you have to do on a super computer if you do not have a Viz node, like what you do on your actual laptop. And like Mary said also before class, counts tables overall are really not that big compared to your giant BAM files. So you can pull your counts tables or your differential expression results, which we're going to go over in the next 2 days, onto your local computer and then work with them on your RStudio that you guys installed today. So if Ariel does not have R, he does not have RStudio.
I bet you can use your computer again. She tried something different.
Okay.
We'll try. Robin and I are troubleshooting this while you're doing that.
A little bit of technical difficulties, but it's expected. It is.
No, to the help.
Here. Which thing?
Your computer, she needs to be plugged in.
Oh, I see.
Yeah, it's, you know, who knows if power's actually going to work, not like this is power.
Because at least one site says that it has to do with the way the battery saver works.
Okay.
We'll see if that
Sorry, I
works.
misunderstood what you were saying. Big old wad. A lot of today we'll be working through, so on ShortRead website, there is a script that's called Learning R Script. Be sure to download that. That is what we're going to be working on for most of today, and that is about learning R. And you're going to use some of the preset data sets that are part of R to practice working with these data frames, practice doing these basic operators. The very beginning, I will show you. At the very beginning, I would like to show you like what you see in RStudio and what each panel is, and beyond that, like a lot of this you guys can start to work through on your own. Now might be a good time if anyone doesn't have RStudio installed or is having trouble with it, can you put up a red sticky note and someone can help you.
Ariel following along, so you're not even behind.
Well, we'll just try to go relatively fast. Sweet. So we are on the part where we can move over to actual.
Try this, because I did the magic key reset. I tried a magic key reset.
My computer doesn't like these adapters. Well, it's happening to Mary's too, so it can't be just mine.
Let's try mine.
So on this, what you want is the underlined script that's learning R script.
Yes, I did. See if we can get RStudio up on mine.
And then
Test it.
really quickly, let RStudio open up. It looks like I had this open last. So all of this is written out at the top of this script. When you have a like pound sign, hashtag in the front, it means your code won't run. So that's called commenting your code. Commenting is a really good idea for things you want to like make a note. Here, something weird happened. Hashtag weird thing, right? It's kind of like keeping a script is almost like keeping a little bit of a lab notebook for what you're actually running on your data. And these comments are really useful for keeping track of things you notice while you're doing your data processing. Generally what's on here in RStudio is you have this top piece, which is your script itself. This gets saved as a .r file typically, but as you know, extensions don't matter all that much. Here is your console. This is like straight like your command line, like what we just did. Nothing here will be saved, but it's good for running like quick things, like if you're trying something out. Up here is your environment section, and your environment is where all your variables will be stored. So like if we remade that list, which you'll see in a minute when it pops back up, 1, 2, 3, 4, and run it. Now that it will appear in the environment section whenever the screen turns back on.
I'm gonna try mine and see if it shows up better. I tried some magic food thing. Our studio's already up.
Mary has lots of
Sorry.
variables set. So it's a good example of what is going on in an environment if it pops up. It's okay. Top right corner, all your variables. Then this bottom plot right here, you can see that it has on the bar options for files, plots, packages. This is where if you generate a plot in R, it'll pop up there. If you want to go to a specific file, you can click on that and it's like going through folders on your computer. It's just an easier way to navigate in R. So like files, you can see here are all of Mary's files. I'm sorry.
Can you make the font bigger on maybe?
I think we're just gonna, this is about all that I really needed to say. So we're pretty much through this. It's still flickering, but those are the main 4 things. The only other thing that you really need to know to be able to run this script, and like I said, there's a lot of instructions on this script for you guys to keep for whenever you want to run R in the future for reminders. But if you hit Control Enter, it's how you actually run a line in RStudio. For example, I don't know if I can run any of Mary's lines.
Yeah,
It's not going to work.
Do anything helpful.
There we go. Oh, Linux PC.
The script,
Not Linux, it's Windows.
Oh, Windows.
the good news is the script is very well annotated, so you maybe don't even need me. But you can either hit Control Enter to run a line, or there's a Run button that's available at the top of your script panel in RStudio.
You're
Poor
handling this
Taylor.
very well.
I'm sorry you're having to deal with this. We told them about this last week. They're like, no, we tested it. Our machine was fine. Our machine was fine.
So is what you guys can do is, oh good, I have my thing open too, is say go to a line,
So she has downloaded Learning R from the website and opened it.
yep, and like you can go to this line, say I want to run this line set working directory, which this directory will not exist on Lynn's computer, which is totally fine for now. I can hit Control Enter, it'll take me to the next line and run it, okay? So your working directory is kind of where all the magic happens. It's literally where you're actually doing your work in R. I a lot of times will use my working directory also as like an output directory. So I'll work in that directory and then say, okay, save all my stuff to my working directory, and then everything's there. I know where all of my stuff is. Does that make sense to everybody? It's like going to a folder and making a file in that folder.
In other words, make yourself a working directory and then set it to that.
A lot of times I'll make my working directories like usually on my desktop and then move them later so that I can find what I'm actively working on. But for starters, just go ahead and start with data iris and run this cell. That will pull iris into your environment where all your variables are, and iris is just a data frame of irises. So like I said, I'll probably just go through this first section and then let you guys go at your own pace. But the name command says, okay, what are the column names for iris? And it will tell us. We have sepal length, width, etc. And like what we used on command line, we can take a iris, the data frame, the $ calls a specific column in that data frame and run it. And we're actually going to sum along that column, just like we did that list, right? And you can kind of, it makes sense because essentially one column of a data frame is a list, right? It just exists with other things around it. We can run it and get our mean and standard deviation like before. Now, if I were to just, this won't be in your script, but if I were to just type out iris and run that to see the whole data frame, it's going to kind of give me this big old snarly thing. And like your gene lists, they're going to be really long. You're not really going to want to try to look at all of them at once. So you can run a head command just like you can on command line. The syntax is a little different, but it will do the same thing. We'll see just the top of this file. And the same goes with tail. Head and tail are top and bottom. The summary of a data frame will give you some of those summary stats, but for the whole data frame, in a form like this, where you can see, okay, like what am I dealing with quartiles, with means, medians, to give you a general sense of the, like, I don't know, shape of your data is a good way to think of it. Dimensions useful if you're like, how many rows are in this stinking thing? Like, how big is it? So that's kind of just some of the like really basic uses of R, which is that first section in this. And now what you're going to do is start to work through this with another data frame that exists in R called mtcars, and it's a data frame about cars. So go ahead and do this section, and you can use the like iris as an example of the syntax and things that you would use for the same steps for mtcars.
Okay, go ahead and work through it. Red sticky tag if you need help. Empty cars. I never heard that out loud. That's funny. Empty cars. I to play with the Pokemon one you put up, because like now that I've seen it, I want to play with it.
It's good. It's the one I used on this one. And it's sort by like equals fire type, strength greater than 4.
I'm careful. My brother was trying to do something or say something that was so politically, and I went to the Bay County data website, pulled down the county data voting information, because she was saying, like, I don't know, they votes or something. There aren't even that many votes in this county. All of these votes. Don't believe you use it.
Oh, really? Oh, you wrote about that? Yeah.
Want this in. So your working directory needs to exist to make yourself a working directory. You can either create that like you normally would on your computer, which is a folder, or you can use the command that I just typed out. But I don't want to run this because I don't think it'll do anything.
Which one?
But I don't know any of the directory paths in this because it's not my
That's like the
computer.
important part. I know. I like that.
So yeah, just you can do, typically it'll be like users, desktop, folder.
Because you're looking for it on AWS.
No, this is all local. So it's different for everyone.
Oh, I see.
But people are, this is, Lens. Yeah, it doesn't matter.
People are confused.
Well, they're trying to set their working directory, but the directory doesn't exist. So this is how you can make a directory.
I see. Right.
Let's just, whoop.
Well, I usually make it myself. And it takes a while. No way. My mom said, I'm talking to you, but I don't know if it's going to make hot sauce. Yeah, I'll start rolling it. Okay, Mom. Yeah, that's what I've been using with color. That's it. I mean, yeah,
R is now SE2. We're going to use your.
I'm about to say
Guys,
that,
our studio is on.
but I want to
your
see how many
computer. It is
sections.
not on the server. It is not on the supercomputer. So the app or anything you're working with is going to be on your computer, not supercomputer.
So there's 5 sections in this, just keep working through those sections. So you have questions, put up the red sticky note, and when you're done with all 5 sections, put up your yellow sticky note. If you don't finish, that is fine, this is just practice to actually learn how to work in R.
So everybody hold their stickers down right now, because you're probably not done with all 5 sections.
Yeah, if you're done with all 5 sections, that's when you put your yellow one up, and once enough people are there, or we hit probably around 11:15, we'll move on to feature counts where you guys can actually generate your count table based on your BAM files. So both feature counts and DEC, which are the 2 programs we're running today and tomorrow, both run on R. That is one of the reasons we are practicing R right now.
No, but DnA says my position is right. Let's see why you're gonna finish. 3 years from now, yeah. We would honestly feel like you should.
You're right, it's the exact same.
I did. It was me not knowing my path.
So here, we actually.
I used the mount C and
Guys, when you guys set your working directory, if it didn't exist, it'll still create this variable. This is a fake path. This doesn't exist. But when I actually try to set it, you'll see in your console that it cannot change to this working directory. So make sure that you set your actual directory to a directory that exists and that this red thing didn't pop up in your console.
You guys realize that right next to console is a little tab that calls terminal, which means you can just go make directory, whatever directory you want, just like you do on a Linux box.
No, that didn't
Pop
work.
back over.
I don't think that's true for Windows, Mary.
Maker is actually Windows, but CD and Maker, everything should work. Those are both great.
Oh, I didn't know that.
I don't make directories in a Windows.
Here, let me
I
try.
know, like, nobody knows all the stuff.
No. I used to also not think about it.
So that does work.
I don't remember it.
But those are basically the only two commands I think that transfer.
Okay, all right.
That tells you all, but
I don't know.
If you got that red error, you can make your directory using that dir.create and the path that you're trying to send to your working directory, then it should work. But you'll run into issues. It'll still go through, you don't have that working directory, but once you try to save your first plot into your working directory, it won't work because that directory doesn't exist.
If you're really having issues, remember this is on your computer, you can just make it folder like normal.
Yep, you can just literally.
Try it on the command line first, but sometimes you just gotta do what you gotta do.
Yeah, you don't need to reinvent the wheel, right?
That is real love language.
Okay. So everybody should have a variable like this that says work directory in the path to your working directory. And if you don't, then you need to run this line again with a directory that exists, right? You can just make a folder if you need to. The other thing is when you're running a line in R, you don't need to highlight or go to the beginning or end of any line. You can just hit run and it'll run that line. Hit run again, it'll run the next line if your directory exists, like this one does not. But you don't have to like highlight or do anything crazy. You also can't really run multiple lines at once right now. Just keep on hitting run for each individual line.
Okay, I'm gonna point out the computer's talking to you when you get run text. Don't ignore it.
The console here is your output. It tells you everything you're doing and if it's working or not.
Are you gonna show them a bat and a flat? Like using it for software. So clean it to
clarify, guys? You should have changed the text right here. And right here. Both of those should have been changed in this block of area. This is your script. You want to change your script. You should be changing your script. Yes, you should be changing that in your script. And 3 lines above it. Those should both be to your positions, not Taylor's.
Are we going to use this script later?
Yeah, well, you're using it today, but yes, save it for your own personal information.
Oh, I see.
You don't point that to Taylor's directory or to past the working directory. You save it, your script as that changed. Change the top of your script and rerun those lines if you did not change it before. Okay. So someone just asked where is it grabbing the data for Iris and empty cars? Those are both data frames that are already existing in R. They live in R to teach people R. You will learn how to pull in your own data soon. If they start with a data frame that already exists, so you don't have to figure that part out ahead of time.
I'm studying. I have DnA's using like versions, but I like it. No. I just literally am doing the dev.ops command, and then I put my apps to work. Oh, is it just say that it's a working directory? You're running that command, and I was gonna say the working directory. Oh, okay, yeah.
Right, yeah, okay, yeah. So basically, that's personal, here I am. This file, divided this twice, so you might have to write in this.
I think DevOps. You didn't say it in line.
So now you're just gonna run into the DevOps.
So this is. What are you talking about? So it's good. What?
this working directory thing. So I think we're gonna do a little quick just demo. So if you're a little confused about this working directory thing, go ahead and take a look up here. So I'm gonna make a new R script so it makes more sense, okay? So here is where your script goes. Here is where you're actually typing, okay? These two positions do not necessarily talk to each other. They only talk to each other. What? Okay, the top and the bottom do not talk to each other. Also, neither of these talk to GitHub or the supercomputer, okay? So the supercomputer we are not on, your GitHub username makes no sense to this computer. This computer knows nothing about GitHub or the supercomputer, okay? This is your home computer. It doesn't know anything. All it knows is what's on your computer, okay? So when you first get in, sure, go ahead and type get working directory. When you first get in and you type get working directory, it tells you where files are going to be stored if you saved them right now. If you just save a file, which we don't have a file, but we could save a file like Iris somewhere on your computer, it would go to that position, okay? We want to instead make it go somewhere else, because if that position is set to, say, your desktop, you don't want everything you're about to do to go on your desktop. You would be lost and not be able to find anything. It's like, you ever have that lab mate who sticks everything in the fridge without putting it in a box? Anybody got one of those? Yeah, that's you, okay? So don't do that. Instead, we're gonna make a box to put all your crap in, so your lab mates don't have to dig through it, okay? What's the box? It's a folder on your computer somewhere, okay? So working directory is a folder on your computer. Let's set working directory in the script for now. So do it up in the script part.
Oh, in the script.
Yeah, there we go. Okay, so at the moment when something is in your script, it has not yet been run. It's just sitting in your script waiting to be run, okay? You can run the same command in your script as in the bottom. That's true for bash too. Do you remember how we were making scripts and submitting them? And you can do pwd in your script or pwd on command line. Same thing here. You can set working directory there and set working directory here. But until you run the script, it does not happen. So this is like that person who says, I'm going to write a book and never does. Okay? If you put it in the top, you're saying, I'm going to set my working directory, but you're not doing it. What does it is the run button. When you get up there, you can push the run button, and now
Yeah,
it
some
will
people
run
are
down
getting
here,
this.
if that exists.
It exists.
It just doesn't like that spacing. It may be Mac.
No, I think it's a permissions thing, I don't know.
Okay. Anyway, up there at the top is where you are creating it, but not having yet done it. Now, how do I set up my scripts? I do not want to have to remember how or when or what I did, because in 6 months, I will not remember how or what I did, okay? So when I'm doing it, I don't type in the bottom unless it's just looking at something. So
Because
if
if I
it's
type-
head, tail, dimensions, number of columns, that I will do in the bottom. If I am actually manipulating anything, I do it up in the top, and then I run that one line.
Because if you set variables in the bottom, but they're not in your script,
They go away.
you cannot recapitulate them.
So what you should do is, unless it's head, tail, number of columns, it should be up in the top, and you should hit run. Okay, what happens if I set my working directory to something, and then I set my working directory to something else? Okay, so I put in there set working directory, I did a bunch of crap, and then I did set working directory to a different directory. What happens? What? That's right. So when you run one line and then you run another line that changes B's working directory, whatever, it will write over the last line. Another good reason to use scripts, because I know I was terrible. I once had one script importing another script, and I had set my working directory, and then I would import the second script, and the first script had another working directory in it, And so I couldn't figure out where the heck my crap was going because it was overwriting it every time, okay? So keep your scripts, write everything you're doing in the top, and only do you ever use the bottom if you're doing something like header tail. Otherwise, it should be written in the top, and you should keep it at the top. And you should hit the run button, okay? Does that make sense now? What's the difference between the top and the bottom? Top is I am saving it, does not work until you hit the red run button, and it will not work until you hit the run button. Bottom, it just happens immediately. Okay, sorry, interrupt, but a lot of people are having that confusion. If she hasn't run D yet, if she has not run line 6, and she types D in the bottom, what will the bottom say? Yes, exactly. If you run D, if you haven't set D except for
Clear
it will
variables?
say, you didn't set D, I don't know what D
Clear
is.
variables?
You didn't run."
Control L will clear. Oh, I don't know if that clears. I usually use the little broom to clear my environment.
No, but I need to clear the variables.
Oh, I don't know.
I know, right?
You can call it L. And actually there is
I know, you use it what you need.
I use it whenever
Like-
feature counts and DC, and then I use it.
And plotting, like, that's all I use it for.
Yeah, I even just I do all my plotting in Python, which is like incredibly inefficient, but I still do it.
I mean, it's kind of inefficient to go back and forth too, like,
kind of
because you have to, because R, you have to like manipulate everything so it's in the right format. I hate R, but it is very useful for some things.
So and I was like, I'll take one for the team and take RNA seq days. And I got away with not teaching my first year.
Gotcha.
Line I type last and I beat
The sound director should be and.
That's what this is.
That's what those two are. And then you're calling those two variables. Along with strength. So what do you want your directory to be?
I'm guessing that I'm trying to get out directory that contains one list that contacts one list that comes live, right?
Well, you don't want that. Your out directory is just string to the directory. So you need to do one single string to an out directory. Made all of these. What do you want your out directory? And that's what we change. Your out directory instead of
Right.
many out directories.
One.
It should just be one.
No, no, yeah.
Hold on a second. Yeah.
Oh, so it's using forward slash.
No. And already in the useful, it's not.
Oh, this is the base generate.
Yeah, so backslashes will not work with R, forward slashes will not work with Z. But they equal the same.
Okay, yeah, I can use a backslash.
R you need to use that.
Oh, okay, that's correct.
Yes.
The one that goes like this. Constantly around. It is weird that nothing went to that folder, right?
You actually have to.
Yeah. Yeah. I tried running it, and it didn't.
Probably because it could take.
Oh, you're right. Yeah, because it should only end up in one, and I have.
Because I think you need to create. There might be two backslashes for each one. Probably, that is not.
My goal is to make that make sense.
No, you just want one after.
Okay, so I need 10,000 directories. That's right, right? Oh, wait, no, maybe it's like. I have 150 directories. So I think-
But then actually.
It won't make that. Yeah, when I do the directory out, it won't make them. Yeah, I guess. Yeah, but I don't know how to change the date, yeah.
Like, that's part of the, so if you're going on to section 4, the whole start of section 4 is explaining like what a package is and how to install it. So if you try to filter without first installing tidyverse, it won't work.
You should be reading the comments, not skipping them because they're green.
The green will not count, but explains what you're doing.
That's a lot of people.
Like, kind of the point of section 4 is like what's a package, how to install a package, and then run is your install package line should be commented out. You need to uncomment it to run that line. The reason I did that is you want to record when and where you install your packages, but you don't want to install your package every time you run a script. So run it once, but save that, because you're like, oh, I used Tidyverse here. Here's where I installed it. So in green, it's hidden in there.
It is good technique to install your package in your script and then comment it out. She used good technique.
Like, remember, your script is kind of like your lab notebook for data analysis. So it's good information to save.
And also say, like, yeah, we added. Called it using the.
Yeah, now it's good. Now it's free after. And now that we run this one, your computer will do what you tell it to, whether you want it to or not. It does that. Computer should do what I want, not what I tell it to.
Yes, you can. We're the ones who built it. It'd be nice. You also just feature us for the sub-report.
All right, so you but the problem is that I have this file when I install. So I
Is it up here? Where is it? Green is 0.
But that was working on.
had a typo. Because I made this plot in like 7 different ways until I decided how I wanted it done. No, because everyone's already pulled it. It's all the way in advanced plotting. I made a column called color with different color names, but this needs to be species because this data frame, I didn't add, there's no color column in. Learning R, yep. It's in section 5 under what if I want exact colors.
Okay, because I'm typing on line 309, it's not taking.
Down a little further, when you make the big G combine, it's got the same thing, color factor, color.
You can tell that I added a column called colors. That could also be it, how would you color column called? G combined was just trying to show you that you can, you don't have to have all your plotting in separate lines. It can all be together. SPECIES. I'm about to get it. Ready?
I was going to use it, but
Eventually we'll be able to do it.
Yeah, just so you can see. Very long way to say it, just look like. I love that. You know, people really think so much enthusiasm.
I'm pretty sure. You might open the homework and just talk about ads.
So good.
This
All right from the front. Oh, okay, that's right. I was gonna say they go to bar. That's high, that's right. I feel like it comes up all the time and someone else answers. That isn't what I come up with. I'm like, yeah, you got it.
You want me to go somewhere in particular, Taylor?
No, when we're almost done with class, because, our subread is not installed on this machine, on the AWS machine. So I was
Okay,
just
but
gonna
I
show
can
it
bring
to
it up.
them. Yeah,
Is it at shares?
it's in shares homework, day 6.
And then once you pull that off, I'll take those based on both of the pieces as well.
Yeah.
Oh, so then we have this thing here. I mean, let's try something like that. Okay, I'll try using this.
Yes, so now select the. Access from access. On your.
You guys raise your hand if you're on section 4 or 5, which is tight verse and GG plot.
4 or 5, are you on 4 or 5? Most people.
Okay, so most people, you guys can keep working, but I want to go over what goes into feature counts as you guys kind of are finishing up. So, you want to, like Mary said, BAM files are really big, so you want to run feature counts, which all feature counts is really doing is saying you have all these reads in your BAM file, here's gene A, how many reads are on gene A, and you're counting. Now these count tables are used for a lot of your, like, okay, you have this map file, what do you do with it, right? Your counts are what informs, like, what genes are differentially expressed. You can also do a lot of different things with them, like look at histograms, counts, and you'll use your count table for a lot of the normalizations that you do in data processing in general. So it's a really important step in your data processing. Once you have your counts table, you can pull this onto your local computer and do some of the filtering you've been working with now on your counts table through RStudio, as well as running DESeq after. So, ideally what we would be doing would be running this script that I've put in on the AWS instance for you guys, but we do not have the package, which you guys are learning about packages. This package is not globally installed on our AWS instance, which means we don't have the tools to actually run feature counts right now. Does that make sense?
Except for that they may not know what global versus local install is.
There's no package on here right now.
So local install is what you did, and we could all local install in the supercomputer, and we'd probably kill it. So instead, we're gonna have the IT guys global install, which means that everybody in the room will be able to use it. He will install it to all of your ones.
It's kind of like the other day when you guys did like module load, fast QC. We want to do that with our subread, which contains feature counts, which is what we would be running. But yeah, since we can't module load it, we can't run it at this moment, which is okay because I'll still show you like what this script is and what you guys would do to run it if we could. So You guys are really familiar with this already, right? At the top, I'm just setting a working directory for running your actual counts. And on this small data set you guys mapped, the chromosome 21, counts will go like that. Typically on a full data set, I would say with 8 CPUs or threads, which is in this one of the scripts that I'll show you, you can run multiple threads to do your counts. It would take about an hour, sometimes longer if your data set's bigger, but it takes a little bit. What?
Feature counts?
How long do you think feature counts takes?
I mean, it depends on what you're doing, but like 2 to 5 minutes, assuming you're just looking at protein coding.
Oh, I'm not just looking at protein coding genes.
It depends what you're doing, right? So sometimes fast, sometimes longer. We talked about packages. Here's install tidyverse. With these, like our subread, you actually have to use essentially install manager, which is all that this hashed out part is. This library line probably looks familiar to you guys also. This is how you loaded tidyverse into your environment. So this is saying load our subread in so that you can actually run feature counts. Then you have to point to a lot of files, which you guys are used to from last week. And here is where at BAM directory, this is where all your BAMs are located. Or you could go to cooking show. Then you actually put in all the names of your BAM files. Here's just 2, but you guys had 6. And your output for your actual counts. Let's get to this is the gene file you're counting over, which is provided for you. This is off of RefSeq. It just contains all your genes in the human genome along with intron exon information, right? If you're looking at RNA-seq, you probably only really care about your counts over your exons. So that information is contained in this GTF file, which is mostly genomic coordinates. And then this guy is what I was trying to kind of hurry up to. Here's your actual feature counts command. And there's like a lot in here, but most of this is just general flags that are from feature counts that are telling it things like the files are, here are my BAMs, the annotation, here's my genes, count over my exons. One of the most important ones here that you guys will probably have to change for whatever project you're working on is if it's a paired end or a single end project. So this is based on your library itself. And the way that this is set up is you can just do a S-batch this guy out to your supercomputer. It'll, in this case, run on 4 threads. If you're running on a bigger computer, you would do 8. So typically this would just be 8. I pared it down for this because I thought we'd be running it. And then it'll paste a counts file into your out directory. So this is pretty similar to the scripting that you guys did last week. It's just using an R command itself to actually run the counts.
So this is a little weird, right? Because you guys are working in R live. But it turns out you can make an R script, and if you have it set up correctly, you can run it on S-batch just like you've been running every other script. You kind of do it a little bit weird because you make an S-batch script that runs R that takes in the script. But we will show you how to do that tomorrow, because the first step is writing your script, which is what you guys were learning about today. And tomorrow, you're going to learn how to run an R script on a supercomputer. You can do it live. You can literally go on the head node, just type R and work through it. It's not a good idea. It's better to set your script up so it's ready to go and submit it to the queue just like every other script.
And you can imagine, right? You guys have so many BAMs. Imagine a situation where you have 12 samples and you're trying to type all those out on R and command line. You're probably going to make a mistake. So doing it in a script like this helps you prevent those mistakes. Yeah. So this is actually just like the script that you guys are working on. So you don't actually have to tell it you're working in R. What we'll do is we'll call it on R through our S-batch script. Yeah, that's a great question.
I think it was actually a little confusing. You cannot run this particular R script with S-batch. You need 2 scripts in order to run this.
Because what you're going to do is you're going to run an S-batch script that runs R that runs this script.
Sorry, that was confusing.
It
But that's all I really wanted to say about this because we're not going to be able to run it today. We will definitely talk more about it tomorrow. But I wanted to give people a chance that are finishing up to finish up here if they would like, or if people are done, that they can head out and meet us back up at office hours if they would like.
You want to show them their homework real quick?
Yes, perhaps. This is not my computer. Okay, so your homework,
If you
there,
hold shift, it will show them in the right place. Hold shift and reload. There you go. I put it under homework now. It was under regular stuff, and now it's under homework. There you go.
so your homework is actually more of this, where you're actually pulling in a data as Pokemon. You guys get to work with some fire types tonight. And manipulate data frames, work on your plotting, and using this learning our additional practice script.
So the one thing I would suggest you guys do for the homework before you leave this room, if you don't know how, is to read in a data file.
And it explains how to do that in this script.
But that's where you're gonna have the most mistakes, is just reading in the Pokemon data file. So do that first
Is it okay
step
if I
before
save
you
it?
leave the room.
Yeah.
Because if you have a problem, you'll want help with that before you leave.
Where are we doing?
It was on your desktop. I was just trying to open that file. The learning our additional practice. Thank you.
That is an R script, so. Learning R, additional practice.
So where I have in this file data and a full path to where this data is, you'll just have to put in the path to wherever you download this CSV file.
In other words, you're downloading the R script and the CSV, but then you have to change the path so that it points to the CSV. That's what I suggest you do before you leave, to make sure you can read that data file. Once you can read that data file, the rest of the homework should be easy.
And you know, like this one, it's divided into steps like we had today, 1, 2, 3, 4, and 5. So if you have any questions about the homework, you should be able to refer back to the script you've been working on today and get some help from that script.
Okay, try and read that file before you go, and otherwise keep working on the script. We'll be around till noon, trying to get you guys through R.
No, it's all good. Didn't want them to try to dispatch an R script, although they
Yes,
probably
I
still will.
appreciate that. That wasn't clear.
They might still.
Well, I didn't know how to navigate to the,
Just do it with my SPatch. Run R and then feed it to the file.
if you,
Yeah.
I have,
Okay.
Yeah.
can you go
Oh,
to,
you mean two scripts, like an R script and an SPatch?
would you actually mind getting me to scripts on this?
To this,
It's
the
in,
share scripts.
yeah, the share script.
You gonna build an SPatch then to run that to them?
They already have it. I just,
Oh, wait. Oh, they do, it's in the same directory?
must be day 6.
Ah,
Yes,
right
that's
there.
it.
Good, okay. Yeah, I was gonna say, color, Elf Lord. Oh, what do you like?
Well, the one that I was on was Slate.
I like it.
I like slate.
All right, guys, so like
The
I was
red's
saying,
a
with
little.
submitting SBatch for your feature counts, this is how we'll do it, is you actually have an SBatch script that you guys are familiar with, and then we're calling in our script feature counts, and then it will run it as a R script.
Does that make sense? So your script is called feature counts here, and then it will run the R script. So you know an R script and an SBatch script. The SBatch script will run the R script.
So you do all your editing in that R script, and then you just submit it out to the computer.
So this is what we're doing tomorrow morning. You don't need this right now. Tomorrow morning, this is after we do the capstone, which will be a little longer than normal. The first thing we will do is run feature counts, which is counting reads per feature. But the reason we're learning R today is because tomorrow you have to be able to make an R script that you then run. And if you don't know how to write an R, then you won't know how to make an R script.
But like I showed you in that R script, a lot of that stuff shows up familiar, right? Like data directory, output, et cetera, et cetera. Thank you.
Sure.
so that people see it as a picture.
these four correspondence again to email. Yeah. Okay. Sweet. You know what? Yeah, he was like, actually, sorry, I misread your symptom. You should not be able to recover.
I did that once. I went to my last prenatal, 38 weeks, and it was Robert broke me because I was so swollen that way. I could not ride. So I said, it's ready to go to a hospital right now, but it's 10 o'clock. We're like 10 o'clock. And I was like, no, you're going to the hospital right now. They said you need to, you're starting right now. What's funny, it was student lab, so was Joseph. Both of them had made titles about each other. Joe and I students, both titles had the word worked in it. You know, it's really, you know, and Robin's like, I can't go, I'm probably going to go to the hospital. This is your fault for using the word work in your title.
You manifested it.
Constantly
I think it's like one of the Canadian bands.
So we banned the word work. I don't know from, okay?
You read the abstract what? Wow, my grandma sent me a WhatsApp video. And now yeah. Is that COVID? You drink enough lemon juice, it can't be down your throat. I actually got a bunch of this from all my WhatsApp. There's my favorite one. It's just like, if you drink water, once you think of COVID, it'll go down into your stomach and you burn. It's like, what's unfortunately,
Any side effects?
not so much. It's really good.
I think so.
It rarely seems like there's the right also I like diarrhea as well. I do. I know where my fucking actually, to be fair, you mostly just have to very easy to send them. Oh, 100%. That's so much better. Also, like, navigating the actual technical difficulties is pretty expensive. You really dealt with it well. What about it? I like it too, as long as I know what
That just means you read it.
if it's like technical difficulties, like,
It'll over-install it. Probably means it
they kind of
I already have.
So, you know, it's just a joke, and nobody laughs.
It's also awkward if you're the only one
It's all about this. It says this part is out there, but it is.
Sometimes I do that, and then it's like, oh, this one needs these other ones.
So do you install packages? There should be a flag for update. Flag for install packages for update.
So you can try.
Make them do samples at some point?
Last Thursday,
That was the day I missed.
they had these
try an R script? On Friday? Sure. You have that R script that you had in the hub? I did that for way more people than you realize.
I believe it.
That's one that you should just run locally. I don't know, like,
Well, you do. I just wanted to see how to turn it into the rank file.
It's just like one line in
That's
the
what
generates the
they're
rank
screwed
file.
up on, because they don't know how to turn it into a rank
oh,
file.
that's funny. I actually used a script for that. I just made a little Python script.
He made an R script that just takes the res and turns it into a rank file.
Yeah, I did the exact same thing, but apparently.
Because it's just kind of like never remember. It's just like the negative. Sign of the logical change. That's the negative one.
Although, do you know what that messes up?
What?
It's really cool. I know it's silly, but DCs can have NAs in the P value adjusted.
Yeah.
Because you're sorting by the P value, not the P value adjusted, they show up as being high, even though they don't show up as differentially expressed. I ran into this the other day, and I'm like, why is this G not showing as differentially expressed? It's beautiful in G to see it.
That's tricky.
I still use the P value because I got some really good results on it. And they're throwing it away because they throw away things that are below the low expression cutoff. And yet, it still gives beautiful results, which means their low expression cutoff is probably too strict. The pathway is up as long as you have a high enough high expression.
See, I feel like long term, this is the really ambitious. It's like we should slowly accumulate all these little pieces of like accumulated institutional knowledge into some central document. Is there a resource? Sorry, and throw these examples together. Like heterogeneous single and variant data.
Oh, cool.
You can do like the counts for those in the proper flags and then just merge them in afterwards.
Oh, that's cool. I like that.
So my standard analysis is isomorph filtering. Isomorph filtering for maximally expressed isoform, which we know is like the most mediocre method. You have to do initial counts.
That's how you did your, and then you use your.
Well, I think we use that as well as multi-color.
It really is, and well, I do a length normalized.
I do RPKM or FPKM.
put an outline. No, I just let it do itself. Oh, I didn't do the homework. No, I did the assessment. So when I'm having the sorting assessment, I think the assessment is what we're having. Yes. Although you have to have an index file to run feature counts.
Oh, absolutely. Hello. Do you get your stuff at Costco?
What?
Do you get your items at Costco?
I do.
Well, I just
bring her to the library the other day.
Yeah.
And I was telling her about the hits I had. She's like, yeah, everybody knows those pathways. No one's seen those. I'm sorry, that's what's different in your data.
Why don't you build me a de novo pathway discovery tool?
Yeah, right? And you're doing something that, if you run something and this is the answer you get, I'm sorry, that's the answer you get.
Also, the more well-known stuff is gonna be better annotated.
It was ATAC analysis, and I did differential ATAC permutations, and she got all the same pathways everybody knew. That's because they've studied this.
Was that something you wanted to talk to me about or something? I forgot about that.
We'll get to that. It's short week where nothing gets done.
Okay.
It really is good stuff.
I was talking about this with Robin the other day, because who else in their right mind would take 2 weeks out of their lab's life every year to teach everybody what they do? Oh,
Well, you have funding for it,
It's
so
our
that's kind
outreach,
of,
yeah.
you know, right?
this time, but we started doing this before we had.
Right.
And
Community
they should, like,
service.
NSF should fund stuff like this, it's a good idea. But
Yes.
NSF's the only one that does, NIH doesn't fund something like
That's
this.
scientific community service.
A little bit of like, actually, having people not as good with it.
It's good to teach people to the point where like anything beyond that is collaboration level.
I'm working on this. I think we should read every day. It's always like, you built a tool to do that, and therefore you can work yourself out of a job. No, we can't, that's why we have a job.
Why didn't I think of that?
I tell you, it really is that joke I put up with, it would just take you a few minutes to run my data through the scripts, right? And it's like this huge pathway internet. No, it will not take.
I mean, I could definitely, given like the pipeline we have in mind now, if we wanted to, we could run full data set in like 2.5 hours. The results you'll get out of that are going to be not informative. They're going to be, hey, look, you had some genes that changed and pathways.
It should be obvious at this point. It isn't.
There's that whole thing we have to consider the after the science layer. You can't just press the science button and kind of figure out the results for you.
Good idea, science button, why didn't we think of that?
Press button when you had it for the experiments you can run in the wet lab. Just give them press button.
I mean, I feel like that's what some people like to show, because the quality of some of these data. People literally just get a library for this keeps on saying, and then we're like, we gotta publish this.
And I even told that, I'm like, I don't have time, you're supposed to do it. If he doesn't show up,
Unless you're like,
And they probably got somebody else to do some analysis that spits something out, and we're like,
yeah.
there's one data set that I really think I was. It should be sworn in to be a little better. The fact that they don't have. So they're using a related that, who's essentially multiple as well as something else. But I still can't tell the student is that they just said, and they, I think it was active units. Like, for the hills from the station, I can't get to the hills.
They're too busy to do this.
I can't tell the standard this, and how on earth are they getting?
Usually it's not too. Stick around, right?
That is better.
Yeah. That is frequently bad.
I have time to frankly teach you how to do RNA-seq. For your high schooler and Dylan's lab, I won't even teach high schooler in my labs privately.
Would you teach me how to do RNA-seq?
For sure you're there, Zach. You can teach me, okay?
Oh, like analysis, not the protocol itself.
Now I'll teach you how to do. You want to go over the wet lab? I will show you the wet lab.
I did my wet lab rotation.
He's good. He did a wet lab. He's held a pipette. That's all we
I
require.
held
of
up
our
that for 8
projects.
weeks.